Hey everyone, and welcome to Programmetry. Today, we're teaching AI how to play and win 2048. We first need to code up a working version of 2048 from scratch. Let's get started. Let's start by setting up the page with some basic styles. Now, we'll add the elements to the page. Looking good! Time to set up the grid. That's looking pretty nice. Let me zoom out so you can see the full page. Next, we need to create the actual tiles. Okay, we now have some tiles on the screen. Yay! But, with that said, we can't actually start a new game or move them. I guess we need to fix that next. Let's set up the controls so the player can slide and merge tiles. We'll also keep track of the score. Beautiful! Now we're able to play the game using the arrow keys. We're able to track the score as well, so the basic foundations of the game are done. Now, let's just see what happens when the game ends. It looks like it just gets stuck. Also, our new game button and high score tracker are both broken. Let's fix these quickly to allow for data persistence and so that we don't have to refresh the page every time we want to restart the game. Nice! Our new game button now works and our best score is being tracked. We're nearly done recreating 2048 from scratch. The last thing we need to add is just an automatic end screen for game over. This will ensure that the game doesn't just get stuck when the player runs out of moves, and so they're alerted when they've lost. Okay, now let's see what happens when we lose. We should, hopefully, see a game over menu pop up. And there we go! Looks like everything is working as expected, and we finally have a fully functioning 2048 game. Now, it's time for the hard part. Teaching the AI how to actually play the game. The first step is allowing the AI to be turned on. From this point on, I'm going to call our AI player Max. Stay tuned to see why. It's actually a cool play on words. We need to give Max the ability to play the game like a regular player, so let's work on that first. For now, just to see if Max can make moves on his own, we will have him make random moves. Now for the moment of truth. Nice! Max is playing all by himself. Let's let it play out for a bit. We can adjust the speed at which Max makes his moves here with the timer interval. Let's see what 80 milliseconds looks like. Okay, that might be a little fast. You can hardly see the tile movement animations. So Max is not very good, but that's because he's making random moves. Let's fix that next. We need to replace this random legal move function with one that actually makes moves intelligently. But before we can correct the random movements, we need a couple of helpers. Max should be able to simulate tiles, a 2 or a 4, spawning randomly. He also needs to be able to check if a board is a dead end, meaning there are no more moves available. Let's add both of these first. Okay, with those out of the way, we can move on to heuristics. You can think of heuristics essentially as measurements Max can use to score board states. These form the foundation of Max's decision-making logic. They determine why Max will choose certain moves over others. Smoothness is an example of a heuristic. It tells Max how similar neighboring tiles are to each other. A smooth board is one where most neighboring tiles are similar to each other. For smoothness, we'll keep track of a penalty that grows with larger gaps between neighbors. This heuristic function is a way of giving a board a score by aggregating the scores of all the heuristics. Right now, we only have two: the smoothness we just defined and the emptiness of the board. More empty cells are good for survival and higher scores, so that's something we want Max to prioritize as well. I'll set arbitrary coefficients for each heuristic for now. We can tweak these coefficients later. Now, it's time to move on to our main AI logic and actually leverage these heuristics. For our 2048 game, I decided on the Expectimax function. The Expectimax function will be Max's main algorithm. Now do you see where his name comes from? Expectimax is similar to the Minimax function. However, instead of assuming that an opponent is going to choose the worst case for us, we use expected value and randomness. It works by recursively simulating moves at a certain depth, while taking into account the expected value of where tiles could spawn. We give it a depth of branches to search. Then, based on the heuristics of the possible boards, subject to randomness, Max intelligently selects the best one. Let's implement it. Okay, let's see how he does this time. Unlike before, Max actually seems to be moving intelligently, based on the two heuristics we gave him. He's already beaten his high score. We can actually see that the smoothness is being leveraged, and Max is trying to keep similar tiles next to each other. This could go on for a bit, so I'm going to speed it up a tad. It's crazy how with just two heuristics, Max has made such a huge improvement. He's already achieved 1024, which is nearly our goal of 2048. So close! Max was close, but I think this run was on the slightly luckier side. Remember that a large portion of the Expectimax function is up to chance. Let's try adding a couple more heuristics. The next heuristic we'll add is monotonicity. While smoothness checks for closeness between neighbors, monotonicity checks closeness across entire rows and columns. We want values to be smooth going up and down, without big jumps. We want a monotonic board. We can't just look at smoothness, because immediate similarities don't always translate to a good board. For example, 24816 is better than 2424, even though both rows have the same log base 2 smoothness. 24816 is good because all values are increasing. 2424 is bad because it involves a direction change. It first increases, then decreases, and then increases again. That's why monotonicity is important. The fourth heuristic is max in corner. If you've played 2048 before, you'll know a good strategy is to try to keep the largest tile in a corner. This stops smaller tiles from spawning between larger tiles and blocking future merges. This heuristic will be simple. We'll just check what the highest tile is and see if it's in any of the corners. Now we have 4 heuristics. I'll make sure Max actually uses these new ones by adding them to the heuristic function. For now, I'll just set some arbitrary weights for each of them just to see how Max performs. We can update these weights later. Let's see how he does now. It looks like he's trying to keep the 256 in the corner. Never mind. That's pretty bad, Max. Maybe just bad luck? Let's try again. Doing better than last time. Still not quite as good as when we only had 2 heuristics. Max might have just gotten very lucky on that 16,000 round with the 2 heuristics. It seems like he might be prioritizing future moves too heavily, causing him to lose early. Since we're just trying to get 2048 and not a high score, let's encourage Max to merge big tiles when possible. Merge potential will be our 5th heuristic, essentially measuring how many merges are possible on a board. This looks at the current board and ignores future potential like monotonicity and smoothness, providing a balance. If a board has a lot of pairs sitting next to each other, that's a good sign. Now, we'll ensure Max uses this 5th heuristic. Let's see if he does any better. Max did decent, but let's try adjusting some of the arbitrary weights now. I'll lower emptiness. We don't want Max to be super cautious and avoid risky merges that temporarily fill the board. I'll also decrease monotonicity. Sometimes a perfect quote-unquote snake structure prevents Max from actually combining big tiles. Max might avoid merging big tiles because he doesn't want to break the monotonic pattern. Finally, let's also have Max look one step further in terms of moves by increasing the depth. This will increase computational load. However, it should improve intelligence and allow Max to see exponentially more possibilities ahead. Let's see how Max does now. Not bad. At least we got back to 1024. I think I'll make one small adjustment. I'll increase monotonicity slightly back up again, to hopefully get lucky with a snake that can get Max to 2048. Let's just let Max play for a bit.
Max got a new high score.
Come on. Max, you literally have two 1024 tiles. Why won't you merge them? Bro, are you serious? Max, how can you be so smart yet so dumb? He literally couldn't have gotten any closer. So apparently we need to emphasize merging obvious pairs because Max can't see them. Let's try this again.
Oh my god, no way.
Come on. Don't you dare do this to me again. Just merge the two 1024 so I can go to bed. No way, let's go! Max, you actually did it. You redeemed yourself. And he's still going. Finally, Max, after so many failed attempts, you actually won. I'm proud of you. Thank you all for watching this far. Subscribe if you enjoyed the video and want to see more of Max in the future. See you in the next one.